Good morning. Today we're going to continue our discussion on not proportional and non-proportional through multiple representations. Before doing that, I want to do a quick review of proportional and non-proportional relationships. So proportional relationships, the most important thing you have to remember is that proportional relationships are a straight line and it goes through the origin. Straight line goes through the origin. The origin 0, 0. So as soon as you have a straight line that touches 0, 0, it's proportional. Non-proportional can be a straight line, but the line does not go through the origin. Non-proportional relationships can also be a curved line. So even if it touches the origin, if it's curved, it's non-proportional. In a table, you can tell if something is proportional because when you do y over x for every single row, you get the same k value. It's constant. It's the same thing every time. Every time I do y over x, it's the same. For non-proportional, every time you do y over x, it will be different, or it'll look something more like the change in y over the change in x. Again, I'm not going to talk about this too much because we're going to go over it in depth in a couple of weeks, but the main thing you need to know about non-proportional is that when you do y over x, it's not the same thing every time. Proportional, it's the same thing. Non-proportional, it's different. The equation for proportional relationships are y equals kx. The equation for non-proportional relationships are y equals mx plus b. We'll talk about that a lot more in the coming weeks. But the big thing to know here is if you're adding or subtracting something, it is no longer proportional. That's changed how it's going. So if you just have y equals kx, meaning a number multiplied by a variable, proportional. If you have a number multiplied by x and then you add something or subtract something, it is non-proportional. So proportional only talks about the rate, so per, each, and, those are the words that tell you it's proportional. Non-proportional also has per, each, and, but they also have a starting amount. So anytime you have a fee or something to add on, or you use a coupon, meaning you subtract something, it's non-proportional. So let's look at some examples for this, okay? So proportional relationships. Sam saves $3 every week. Well, to me, that means at week 0, he has no money. We don't know any information that he already has money, so he has $0 at week 0. Well, after 1 week, if I save $3 every week, I have $3. After 2 weeks, if I save $3 every week, I have $6. After 3 weeks, I have 9, and so on and so forth. So y equals 3x, because every week I save $3. I'm not adding anything, and the line started at 0, 0. You could also tell it's proportional because we do y over x. 6 over 2 simplifies to 3. 24 divided by 8 is 3. 33 divided by 11 is 3. I got the same number every single time. For this non-proportional, Tyler saves $2 every week. He already had $1. Okay, if he already had $1, that means at week 0, he's already got $1, even though I haven't saved any money. But if he saves $2 more every week, so at week 1, he's up to $3 total because I already had 1 to start with. At week 2, he's up to 5. Week 3, we're up to 7. Week 4, we're up to 9. Okay, so I'm adding something on to this. Looking at the equation, you've got this plus 1, whereas over here I wasn't adding anything. That tells you it's non-proportional. That's that starting point. I can also tell it's non-proportional because it doesn't touch 0, 0. The line does not touch the origin. And if I do 7 divided by 3, I get 7 thirds. 15 over 7 is 15 sevenths. 25 over 12 is 25 over 12. It's not the same thing every single time. Therefore, it is non-proportional. One more thing I want to add is that proportional relationships are also called direct variations. Proportional and direct variation mean the same thing. It's just that people who write our tests like to think they're really funny and they like to trick us by using different words. Proportional, direct variation. So since this is proportional, it's also a direct variation. So we're going to talk about graphing this using ordered pairs. Okay, just looking at the equation, y equals 1/3 x. I can see right now, right here, right now, that I'm not adding anything to it, so I know I need to start at 0, 0. Now I need some more points to graph a line. Well, I'm going to pick a value for x, and that will get me a value for y, because I'm going to plug that in. So here, I see that I have 1/3 x. Okay, well, to make your life easier, I would pick values that work with 1/3. So don't pick 2, don't pick 1, pick 3. Pick multiples of 3. It'll make it easier. The other way we can do this is operate using rise over run. So 1 over 3, rise over run. From this starting point of 0, 0, I rise 1, so I go up 1, and I run 3. I go over 1, 2, 3, put a point. Rise over run. So from this new point, I go up 1, and I go over 1, 2, 3, put a point. Pattern going, rise over run. I go up 1 and right 1, 2, 3. I've created a line. But if you wanted to use the other method of picking points, you would pick multiples of 3. So we started with 0, 0. Then for my x value, I'm going to pick 3. I could plug that in for x. 1/3 times 3 is 1. Your calculator can do that math for you. Then I'm going to pick another multiple of 3 because I don't really like fractions. So if I pick multiples of the denominator, I won't get a fraction. So the next multiple of 3 is 6. So if I do 1/3 times 6 in the calculator, I get 2. Next multiple of 3 is 9. 1/3 times 9 is 3. Now we have y equals 3 halves x. Again, I'm not adding anything, so I know my first point is at 0, 0. The first thing I'm going to do is graph this using rise over run. So from 0, 0, rise over run. I'm going to go up 3, right 2. I go up 1, 2, 3, and I go to the right 1, 2, put a point. Then you go up 1, 2, 3, and you go to the right 1, 2, put a point. Do it again, go up 1, 2, 3, go right 1, 2, put a point, and now I have my line. Again, I have fractions here, and so if I want to make a table by putting in values for x, I'm going to pick multiples of the denominator. The reason I'm doing this is because when you pick multiples of the denominator, you will no longer have a fraction. It's going to work out beautifully. So the first multiple of the denominator is the denominator, which is 2. So when I multiply 3 halves times 2, I get 3. Next multiple of the denominator is 4. So when we do 3 halves times 4, I get 6. Again, your calculator can do this for you if you're struggling with this. Then the next multiple of the denominator is 6. 3 halves times 6 is 9. Okay, quick review of proportional and non-proportional. So this is under the multiple representation section of your notes. You're filling in the table. There's graphs in a second. So proportional, the equation is always y equals kx. I'm not adding anything, just multiplying something by x. So we can look here. We have the Earth weight and the moon weight. So if you're 0 pounds on Earth, well, you're 0 pounds on the moon. It touches 0, 0. As soon as the straight line touches 0, 0, it is proportional. Non-proportional is y equals mx plus b. You have a number multiplied by x, and then I'm adding or subtracting a number to that. If I look at here, theme park ticket costs, the number of tickets, even if you buy 0, you're still going to spend $20 because that's probably what you pay in parking. So the line does not touch 0, 0, so it is not proportional. Okay, it says for each situation, write an equation, make a table, and sketch a graph. Tyler earns $12 for each lawn he mows. Okay, the rate is the number we have for each. So our rate is $12 for one lawn, so 12 to 1. So our equation is that rate times x. So y equals 12x. Now to generate this table, I'm going to go ahead and plug in values for x. So the first value I'm going to plug in is 0. Well, if I plug in 0 into this equation, 12 times 0 is 0, so it does touch the origin, so it is proportional. Next, I'm going to plug in 1. If I plug in 1 for x, 12 times 1 is 12. Next, I'll plug in 2. 2 times 12 is 24. And 3. 3 times 12 is 36. Okay? Now, if I was to sketch this graph, right, it's very open here, I would go ahead and count by 12s because then I wouldn't have to make a lot, or you could count by 4s, whatever. I would count by 12, so I'd say 0, 0, and then we'd have 1, 12, and then it would be 2, 24, and 3, 36, onward and upward. Okay, you just have to sketch the graph, but it touches the origin and it'll be a straight line. Our next situation, we have Chris has 50 baseball cards. He will add 10 new cards per week to his collection. Okay, he already has 50 baseball cards. When you already have something, that means you're adding it on. So here it's non-proportional, okay, because I have that starting point of 50 cards. I'm adding 10 new cards per week. This word per indicates the rate. So our rate is 10 new cards per week. Since I had a starting point, I'm going to use the equation y equals mx plus b, our non-proportional equation, and add our starting point. So I get y equals 10x plus 50. Again, we're going to go ahead and start by plugging in 0. At week 0, if I plug in 0 for x, well, 10 times 0 is 0, but then I add this plus 50, so it's at 50. Notice how this does not have 0, 0 as a point. That means it is non-proportional because it does not touch. If you put it on the graph, it's not going to touch 0, 0. Then I'm going to plug in 1. Well, 1 times 10 is 10, plus 50 is 60. Then I can plug in 2. 2 times 10 is 20, plus 50 is 70. Then I can plug in 3. 3 times 10 is 30, plus 50 is 80. Now, personally, for the graph here, I would go ahead and count by tens, and then I would count by ones on the x-axis. So if I count by tens, at 0, I'm going to be 1, 2, 3, 4, 5. So here's my starting point, 0, 0, or it's at 0, 50. And then I go up 160, 270, 380, so on and so forth. The kite has an altitude of 50 yards. It descends 5 yards per minute. Okay, I already have an altitude. The kite is already in the sky. Therefore, you have a starting point. And as soon as you have a starting point, the situation is non-proportional. It's non-proportional, so I have to add on that starting point. Now, one thing you need to be really careful about in this problem is it says it descends 5 yards per minute. Well, descends means it's going down. We're dropping in altitude. Therefore, my slope has to be negative. So our rate is negative 5 yards per minute. So when I write my equation, I say y is equal to negative 5x plus 50. So here, I'm going to go ahead and plug in some points so we can figure out what our ordered pairs would be. I'm going to start by plugging in 0, 0. Well, negative 5 times 0, if I plug in 0 for x, negative 5 times 0 is 0, plus 50 is still 50. But this time I'm going to plug in 1. Negative 5 times 1 is negative 5, plus 50 is 45. When I plug in 2, negative 5 times 2 is negative 10, plus 50 is 40. Then we have 3. Negative 5 times 3 is negative 15, plus 50 would be 35. Again, I'd probably count by 5s or 10s here so that we can make the graph. So if I counted by 10s, we'd be 10, 20, 30, 40, 50. Here's my starting point. At 1, I went down 5, 2, 5 more, 3, 5 more, and so on and so forth. Okay, analyze the following tables to determine the rates, write equations, and determine proportionality. So our hourly rate is for Amy is 5 hours, $40, 9 hours, $72, 15 hours, $120, 25 hours, $200. Okay, so to find the rate here, I'm going to get our K value. So 40 divided by 5 is 8, 72 divided by 9 is 8, 120 divided by 15 is 8, 200 divided by 25 is 8. I got the same number the whole way down when I did y divided by x. Therefore, Amy's is proportional, and I get $8 an hour. Here, when I divide 106 by 8, 106 by 8 here, you get 13.25, but if I do 120 divided by 10, I get $12, and 162 divided by 16 is $10 and 13 cents. So this is not going to be proportional because I'm not getting the same rate each time I divide. Now, to get the hourly rate, which I'm not too worried about at the moment because we're going to cover this in a couple of weeks, it's $7 an hour. The reason for this is to go from 106 to 120, that's plus 14. To go from 8 to 10, that's plus 2. 14 divided by 2 is 7. If you did not understand what I just did, that's completely fine. We have not learned this yet, how to get the $7. It will not be on your test or CFA. All you have to be able to do is tell me that if you divide y by x and it's not the same thing, it's non-proportional. Okay, so since I told you that Dustin's was 7, okay, so Amy's we figured out was 8, so y equals 8x. Dustin's is actually going to be y equals 7x plus 50. We could figure that out because I told you that Dustin's hourly wage was 7. So if I did 8 times 7, well, that is equal to 56. Well, to get to $106, I'd have to add 50. Again, please don't stress too much about this. We will go over that in the next unit. Here's the big thing that you have to be able to determine. If these are the equations, y equals 8x and y equals 7x plus 50, which student received a signing bonus? Well, the signing bonus must be the student who got extra money beyond the hourly wage, and that would be Dustin because you're getting extra money. Which students' earnings are proportional? Well, that would have to be Amy's because I'm not adding anything, and I got the same number when I divided y by x the whole way through the table. Okay. Again, we have a graph here. It says which represents Amy's earnings and which represents Dustin's. Well, we already said that Amy's was proportional, so Amy's has to be the line that touches 0, 0. And Dustin's would be the line that starts at 50. Okay, I'm going to show you one thing with the calculator, and then we have a lot of things for you to do today. I will show you each of them, and then your CFA is tomorrow, your test is next Tuesday. So, first thing I want to talk about with the calculator is remember back here we were trying to graph an equation with points and everything. Well, I want to show you how to do this on the calculator. So, I've pulled up the online STAR practice test, okay? No, we're not doing any of the questions, but I want to show you how you would graph the equation, y equals 1/3 x on the calculator. So, I'm going to go in here. The very first thing that I'm going to do to my calculator is hit y equals. When I hit y equals, it pulls up this list with y1, y2, y3, y4, all of those. Well, I need to type my equation into y equals, so I need to type 1/3 x. Remember, you can type fractions just by doing parentheses, your numerator, divided by the denominator, close parentheses. Then to get X, the button for X is the button next to alpha, next to the green button. So I'm going to hit X. Now, if I want to see the graph, you just hit the button in the top right that says graph. There's my graph. Looks pretty similar to what we had graphed here. Now, if I want to see the table, see how table is written in blue above graph? I would hit second, the blue button, and then hit graph again. And look, here's our table. We had 3, 1, 6, 2. That's everything we wrote in the table without us having to go through and do it. Now, I will show you how to do this again. Now, to exit the table, hit second mode. It'll go away. Let's try the next one we went through. So the next one was y equals 3/2 x, okay? To start, you go to y equals. The steps for this are in your packet, by the way, so if you're lost a little bit, go through and look at those steps. I want to clear out whatever is in y equals, so I just hit clear. Then we want to do y equals 3/2 x, so I need to type 3/2 x, so I'm going to do parentheses, 3 divided by 2, close parentheses. The button for X is the one next to alpha, so it's X, T, theta, and N, so I'm going to hit that. So I have 3/2 x. To see the graph, we just hit graph. To see the table, I'm going to hit second, which is the blue button, and then table, and then there are all my values set up for me. Okay, now back to what we were talking about. So you have the multiple representation activity. You may work in up to a group of 3 for this. Then you're going to do the non-proportional proportional activity. You're going to do this by yourself. And then we have homework 2-7. So the multiple representations activity, looks like this in your packet. Okay, you are going to be getting a K value, the constant of proportionality, writing your equation, coming up with a table, telling me if it's proportional or non-proportional, and then sketching a graph. You have 4 questions like that you're going to work with a partner on. Then you have the proportional, non-proportional activity. So you're going to go through and do this front and back. I actually will let you use a partner on this. So you can use a partner. For here, you are going to draw a line to match it to the appropriate category. Okay. So is it only has multiplication? Is that proportional, non-proportional? Does not go through the origin? Match them up. And here you're just solving the questions. And then finally, when you are done with all of those things, you are going to do homework 2-7, which looks like this, front and back. All right, if you have any questions, please feel free to email me or ask the sub or Miss Zamora. Thank you.